Hello everyone, it's Ishwarya Surana, and today we are going to discuss floating point representation of real number and its consequences. So floating point representation is a way of representing real numbers in computer, and whenever the truncation is done in real number, it leads to error. So what the errors are exactly, we'll discuss it today. Now, associative law, which is something like universal law, is not been verified by this floating point representation. That is, a plus b minus c is equal to a minus c plus b. According to associative law, we know that. Now, if we take the values of a, b and c as nearly equal values like 0.5665, 0.5556 and 0.5644, and if then we will compute the LHS, that is a plus b minus c. When I'll do a plus b, I'll get 0.5720, and then when I'll subtract c from it, I'll get 0.7600 e to the power minus 1. Now if I'll do the next thing, that is a minus c plus b. First I'll do a minus c. I'll get 0.5665 minus 0.5644 even, and here I have found that the value of this is 0.2100 e minus 1. Here e minus 1 is 10 to the power minus 1, simply you can see that. And when I'll then compute a minus c plus b, that is I'll add b to it, I have found that the value of this is 0.7656 E1. So here we can see that LHS is not equal to RHS, that is 0.7600 e to the power minus 1 is not equal to 0.7656, means I'll get an error after 2 decimal places in this floating point representation. So the associative law is not being verified. Then we'll see the distributive law. According to distributive law, we know that a into b minus c is equals to ab minus ac. If again I'll take the values as a is equals to 0.5555, b is equals to 0.4545 and c is equals to 0.4535, then if I'll substitute this value of b minus c, that is if I'll compute the LHS, I'll get 0.1000 E1, and when I'll multiply a to it, I will get 0.5550 E1. Now again, if I'll solve the RHS, I'll get AB, that A into B I would have 0.2524 E2, and A into C I will have 0.2519 E2. When I'll compute this thing, that is AB minus AC, I'll get 0.500 E1. So from this I have found that the distributive law has also been not verified, that is A into B minus C haven't come to AB minus AC. Now I'll see a simple thing, that is while solving a quadratic equation, the quadratic equation which I have taken here is x squared minus 2x plus 2. Here the roots obtained would be, that is the value of x I'll get is minus 1 plus minus under root 3. And when I'll represent this in floating point representation, I have 0.7320 E0 and 0.2732 E1. That is minus 1 plus root 3 would be 0.7320 and minus 1 plus root 3 would be 0.2732. And when I'll substitute 0.7320 E0 in this equation, that is x square minus 2x, x square plus 2x minus 2, and I will take x square plus 2, that is I will compute x square plus 2 first. Then I have got the value as 0.0 minus of 0.1000 e minus 2. And similarly, if I'll do 2 minus x first, x square, then I'll add x square to it, I'll get 0.2000 e minus 3. So in this way I'll get different values for the same root. So that's again a contradiction. Now a very basic thing, we know that x plus x plus x plus x plus x plus x is equal to 6x. That is, if I'll add x 6 times, I'll get 6x. Now let's take the value of x as 0.667 E0. So if we'll do x plus x plus x, that is if we'll add x 6 times, I'll get 0.39998 E1. and if I'll do 6x, I'll get 0.4000 even. So an error is spotted here again. So in this way, the floating point representation is not a way in which we can represent the numbers. So here is the floating point representation and its consequences. Thank you and have a nice day.